Hello everyone, very good morning. So welcome to today's lecture video session. Myself, Dr. Santosh Kumar, Associate Professor and Head Department of Computer Science and Engineering, Saint Martin Engineering College. Today we are going to discuss about the topic 2D convolutional neural network in deep learning. So before that, we want to know like what is deep learning, what is machine learning, what is artificial intelligence. So these three words are not new to us. So as a CSE or other branches, everyone are familiar with these three words: artificial intelligence, machine learning, and deep learning. So we'll see one by one. So what is the description of each and every one? Say for example, artificial intelligence. So what is the definition of artificial intelligence? So everyone can simply say, so artificial intelligence is a machine which mimics like a human intelligence. So why we can say it is mimics like a human intelligence? Say for example, so there is a fire accident nearby us. There is a fire accident nearby us. So what the human will do immediately? So they will take water and pour into that fire, and the second thing they will call a fire service station. So these two things any human can do immediately. So similarly, what the machine also will do same thing. When the machine identify there is a fire accident near the environment, the machine starts immediately pouring water into that place where the fire accident happened, and similarly the machine makes a calls to the nearest fire station, whatever present in their surrounding, it will make a immediate call. So there is a fire accident in so and so locations. So this is authentication information. So you can come with your all equipments immediately. Fine. Now we have discussed about what is artificial intelligence. Now coming to machine learning. So what is machine learning? See, a machine learning is a machine which train the data from the previous data sets. Say for example, see here, there is an image. So I want to extract feature extraction from this image. So this is the image. I want to go for a feature extraction process. So for the feature extraction process, there are different feature extraction techniques are there. Say for example, HOG is one of the feature extraction technique. SIFT is one of the feature extraction technique. SURF is one of the feature extraction technique. So using this algorithm, you can extract feature from the raw image. So say for example, so this is an image which is indoor. So now my problem is I am going to classify the image whether it is an indoor or outdoor image. So I am going to train the machine with both images. So I can label it as indoor and one is outdoor. So with these two labeled image, I am going to train my machine. So for that, I have to extract the features using this algorithm HOG, SIFT and SURF. So once the feature values are extracted from the image, I am going to give the input feature vectors to the classifiers. So say for example, support vector machine is one of the classification algorithm. Random forest is one of the classification algorithm. Similarly, decision tree is there. KNN is there. So there are so many classification algorithms are there. Now we are going to discuss about machine learning. So what is meant by machine learning? We can simply say machine learning trained from the previous data so that it can predict, it can analyze and it can classify the new data. Say for example, how the machine learning will works. So I am going to take a one problem. I am going to identify whether the given image is outdoor or indoor. Outdoor or indoor. See, this is my input image. So this is an indoor image. I am going to extract a features from this image. The extracted feature is given to the input to the classification algorithm. Once the classification algorithm trained with these features, finally the trained machine will say whether my input image is outdoor or indoor. Outdoor or indoor. So this is what machine learning. So then we can go for what is deep learning. So deep learning is a subset of machine learning. So why we can say it is a subset of machine learning? So the same way how we are extracting feature from the image, the extracted feature is trained by the classifier, then finally the output what we are getting. So that is the process of machine learning. In similar way, here also we are going to identify the image whether it is indoor or outdoor. But the thing is, there we can able to see two different parts. The first part is feature extraction and the second part is classification. But see here, the both parts, which means the feature extraction and the classification will be in the same path. Say for example, this is the input image, this is feature extraction and classification, and this is the output. This is the output. So the two different paths, feature extraction and classification, will be happening in the same path, so that we can say it is a deep learning. Similarly, it's going to extract here deep features. Say for example, we can able to extract a low level feature and mid level feature and high level features. Then after the extraction of low level, mid level and high level features, then I can able to identify whether the input image is outdoor or indoor. So this is what the deep learning. See here, the one more we have discussed in the previous slide. If it is a machine learning, input image will be there, feature extraction part will be there, classification will be there, output. Then coming to the deep learning, the only difference is the feature extraction classification will be takes part in the same part. So there are three parts only: input, feature extraction plus classification, output. So to combine this feature extraction classification in the same part, we have to move with this deep learning. So what is the difference between these three? Artificial intelligence, machine learning and deep learning. So as I earlier said, so AI is going to mimics like a human intelligence, and machine learning, it train the data from past data and it going to classify whether the given image is yes or no. So deep learning, it is a subset of machine learning. So here also the feature extraction classification part takes place in same part. And see what are the different applications in deep learning and architectures of deep learning. So deep learning architectures is divided into four parts: that vanilla neural network, deep neural network, convolutional neural network and recurrent neural network. So coming to the applications of deep learning, so there are image classification, customer statement analysis, ID document analysis and effective image restoration and language translation. So these are all the major applications part in deep learning. Now we will come to the convolutional neural network. We will come to what is convolutional neural network. See, convolutional neural network It's comes from artificial neural network. So each and everyone will be very familiar with the artificial neural network architecture. So ANN architecture, which consists of three parts: input layer, hidden layer, and output layer. So input layer, hidden layer, output layer. So this is the basic ANN architecture. So from here only the concept will comes, which means the each and every neuron should be connected with the each and every neuron in the another layer. So this is the basic CNN. Basic CNN consists of input layer, hidden layer, and the output layer. So now we'll move to convolutional neural network, CNN. So CNN also consists of these three layers, but the difference is there is a input layer, there is a n hidden layer, and there is a output layer. So what is meant by n hidden layer? So instead of one hidden layer, there will be a sequence of hidden layer. Hidden layer 1, hidden layer 2, hidden layer n. So based on our task, the hidden layer may be increased. Say for example, I have taken a binary classification. So what is meant by binary classification here? So as I said in previous slide, I am going to classify a image which is outdoor or indoor. So here we are going to classify outdoor or indoor. So it's a binary. Then another part is there, it is a categorical classification. So what is meant by categorical classification? So I am going to classify more than two classes. More than two classes. So what is meant by more than two classes? Say for example, I am taking a problem like I am going to classify human emotions. So what are the different emotions are available? Human emotions. Say for example, angry is one of the emotion. Happy is one of the emotion. Sad is one of the emotion. So now I am going to take only this three. So it is a categorical classification. Why? Because more than two I am having. So whenever we are dealing with this more categorical classification, we have to increase our hidden layers. We have to increase our hidden layers, then only we can get a good accuracy performance. So what the convolutional neural network says, convolutional neural network which consists of hidden layer, input layer, n number of hidden layer and output layer. See here, what are all the terminologies are there in the convolutional neural network. So terminology in the sense, what are the keywords we are using oftenly in the convolutional neural network. First one is filters. What is meant by filter? A filter is otherwise called as kernel. So what is meant by kernel? So as we can say, it is a convolution. Convolution is a process of multiplying image pixel with filters. Image pixel with filter, that is called as convolution. So here filter is just a matrix value which called as weight or kernel. And what is meant by convolutional? So convolutional is a mathematical operation that takes a multiplication of image pixel with the filter value. and the third one is pooling. So what is meant by pooling? So the major objective of the pooling is to reduce the dimensionality of the feature, that is called pooling. So there are three different types of poolings are there: max pooling, mean pooling and average pooling. And the fourth terminology is fully connected. Fully connected. So once the input layer passes his features values to the hidden layer, the hidden layer passes his output features to the fully connected layer. Anyhow, it's have a two-dimensional value. That two-dimensional value is converted into a one-dimensional value, which is called as fully connected layer. And the fourth terminology is stride. So when we are doing this convolution process, so we have to take each and every corner of the image. Then only we will get a good accuracy. So that this stride will help at that time to recover or to extract feature from each and every corner of the image. And padding also same thing. When we are adding zeros into the image pixel value, say for example, I will explain in detail in the next slide what is padding, stride and everything. Next, components. So the basic convolution neural network consists of four main layers: convolution layer, pooling or downsampling or subsampling layer, flattening layer, fully connected layer and softmax layer. So let's see one by one in detail. So I have told you like convolution is nothing but a multiplication of image pixel value with the filter value. Say for example, this is the input data, image pixel value. So I am going to multiply with image pixel value in the kernel. This is filter. So the multiplication of image pixel value with the kernel, which gives the convoluted feature, Say for example, in next slide, we will detail see how this was. Yes, what is convolution? So as I said earlier, it's a simple mathematical operation. We are going to multiply a image pixel value with the filter value. So it is a input image, it is a filter value, and it is the convolved image. Say for example here, these are all the image pixel values, and these are all the filters. The size of the filter is 2 cross 2. So I am going to multiply a pixel value with the filter value. Now see the convolved image 1, a function of A I am going to filter with the weight 1 plus B I am going to multiply with the W2 and 2 cross 2 size, so I am going to multiply E with the W3. I am going to multiply F with the W4. So like this, we have to do the convolution for each and every pixel value of that image. So here, number of parameter of one feature map is 4. So say for example, number of parameter for 100 feature is, so 4 into 100. Okay. So similarly, see this convolution layer. We have say what is this zeros? So we can understand this 2, 3, 4, 5, 5, 4 are the image pixel values. Then what about this zeros? So in 2 slides back we have seen padding. So what I say? So padding in the sense, whenever we want to take each and every corner of that image, we have to add zeros at our matrix. Then only we can get each and every corner pixel values of the image. Say for example, I am going to start a convolution with the 3 cross 3 size. With the 3 cross 3 size. See, this is the first 3 cross 3 size matrix. So I am taking 0, 0, 0, 0, 2, 3, 0, 6, 3 and I am going to multiply with this. I will get a one value that is called 7. So next I can say we have seen one word stride. What is meant by stride? So the movement of each and every matrix, that is called a stride. So the first 3 matrix and the next 3 matrix I am taking with this red color. So similarly I can take the another 3 cross 3 matrix. Similarly I can take the another 3 cross 3 matrix. So if I do like this, so there is no chance to missing of any pixel value. So in the image I can able to get even deep features of the pixel values. So I will show you a small navigation. See what is happening here. This is the input matrix, this is the 3 cross 3 filter value, and what output we are getting. First it will take this one, then stride one, stride one, stride one. Like this it is going on. So here I have mentioned a stride one, so that one row it was shifting. Suppose if I mention stride is equal to 2, it will take first this one, then 2 it will take. So this is what a convolution layer. And the second layer is, see, this is one more example of convolution layer. How this is the input image, how these are all happening. Like this stride going on, then the convolved image will be happening. Similarly, stride going on, convolved image will be coming. And the next one is activation function. So what is meant by activation function? So this function helps the network to learn non-linear relationship between the pixel value and the filter. So what is meant by non-linear? See here, whenever we will face a non-linear data, so it is an example for non-linear data. So my aim, I need to convert a non-linear into a linear, so that I am going with the ReLU activation function. So ReLU in the sense rectified linear unit. Rectified linear unit. So the formula says, whenever the values greater than 0, the values remains same. Say for example, x, for x greater than or equal to 0. When I will get 0, the value, the x is less than 0. The x is less than 0, so immediately it will be converted as a 0. When the value is greater than or equal to 0, it remains same. Say for example here, the highlighted blue color are all negative values. So negative values in the sense it is a less than 0. So what is the concept here? If it is less than 0, it will make as 0. It will make the value into 0. Wherever the value is greater than or equal to 0, it remains same. Say for example here 32 is there, the 32 remains same. Here 14 is there, the 14 remains same. Here minus 12 is there, the minus 12 is converted into 0. So this is what the activation functions concept. Next, pooling layer. So the main objective of the pooling layer is to reduce the dimensionality of the features. So there are 3 types of pooling: min pooling, max pooling and average pooling. So see here, it is an example of max pooling. So the pixel values of this convolved feature is this one, 28, 6, 12. So I will take a 2 cross 2 the matrix size. Here, what is the maximum value among these 4? 20. So the max pooling will save only the maximum value. And coming to the next stride, it will take another 2 cross 2 matrix. It will vary. What is the maximum value here? 15. So it takes 15. So similarly, coming to the min pooling, the same matrix. See here for this 2 cross 2 matrix, what is the minimum value here? 6. So it says 6 here. So coming to this one, what is the minimum value here? 5. So it saves 5 here. So the main objective of the pooling layer is to reduce the dimensionality of the feature. So see the same thing in detail I have explained. So take this first 2 cross 2, 7 is the maximum, so 7 saves. Here 26 is the maximum, so 26 is there. Here 22 is the maximum, 22 is there. So the next layer, flattened and fully connected layer. So as I said earlier, the convolved extracted features are in a 2D format. So I want to make it into a model. I need one-dimensional data. So the 2D data is converted into one-dimensional data. So this is what happening in the fully connected layer. So this is the basic architecture of 2D convolutional neural network. The input images are there, convolution layers are there, pooling layers are there, and the flattened layers are there. The fully connected layers are there. See here it is you can divide into 3 parts. So input layer, hidden layer, and output layer. So there are input images are there. I am going to give the input images into convolutional layer. The convolution layer doing the convolution operation with the activation function. Then I will get a feature maps. That feature map is reduced with the max pooling layer. Max pooling layer objective is to reduce the dimension of the feature. Similarly, it moves on to the 2 convolution and 2 max pooling. Then finally it reaches to the flattened layer. So flattened layer converts the 2D data into a 1D data. So fully connected layer here, 2 fully connected layer are used. So fully connected layer process extract all the features from the convolved data, and finally the output layer produces the classes. How many classes we are given? It was classified into class 1, class 2, class 3. So this is the basic architecture of 2D convolutional neural network. So I hope all of you understand this 2D convolutional neural network. So we will see in the next video. Thank you.